Okay, so part 2 for the rest. When solving proportions based on data from graphs, why do you often convert from fractions and percents to decimals? Well, why do we do this? Who did I say the triplets were? Who are the triplets? And what is the difference between the three? That's what they're asking you in this question. All right, on to the next. So here, 11.1 independent practice. Independent means by yourself. That is why I heavily focused on telling you that you needed to do this alone in class. The number of computers sold at an electronics store for each day of the week is shown in the dot plot. Whenever we look at the dot plot, we need to determine what each dot is worth and how many there are total. So, total number of dots is some number, and then each dot is a what? So, what percent of all computers sold during the entire week, all computers sold during the entire week, were sold on Friday? So the desired part is Friday. In your proportion, you're putting the number of computers on Friday, the total number of computers, and X and 100. Here it says what percent of computers sold on weekdays were sold on Tuesday. Round to the nearest percent. Weekdays do not include Saturday and Sunday. And then we want Tuesday. So in your desired part, that's Tuesday. And then your new total is Monday through Friday. Your week days. This proportion box may need to be shown on separate paper. So question number 5. Desired, which was Tuesday, out of the weekdays, X over 100. All right, the next question says, suppose the data described above for the electronics store were represented with a bar graph instead of a dot plot. Would there be any advantages or disadvantages? This basically says, would a bar graph be better or worse? Talk about it. How long would the bars be? If you were in 6th period, you'll know what the comparison between a bar graph and a dot plot was. Don't forget to tell me what each dot is. Questions 7 through 9. The number of states in the U.S. that are primarily in each of the time zones is shown in the bar graph. 7. The continental United States is all states except Hawaii and Alaska. What percent of the continental states, that means not Hawaii and not Alaska, are primarily in the Eastern time zone? You need to label each bar. How many is this, 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 and this? And you should know how many states there are in the U.S., and that will give you your total. But for your continental U.S., that equals your total minus 2. So I need to make a proportion box for number 7. See, that says number 6. 7. So the desired part over the continental U.S. and X over 100. The desired part equals the Eastern time zone states. That's what they're asking for. Okay? Bam. Cross multiply and the divide. Number 8. Is the percent of the continental states primarily in the Eastern time zone greater than or less than the percent of all states that are in the Mountain or Central time zone? All states, your total is now all of the states. The desired part is Mountain Standard Time Zone and Central Standard Time Zone. Central is the standard time zone that we are in. So for number 8, let's turn on my page. Mountain Standard Time Zone and Central Standard Time Zone is your desired over all U.S. states and 100 and X. Cross multiply, then divide. Number 9. Suppose the horizontal scale of the bar graph had intervals of 1 instead of 4. Would there be any advantages of having that scale? Would there be any disadvantages? So instead of counting by 4s, you're counting by 1s, 2, 3, 4, 5, 6, and so on. How would the graph look different? Or how different would the graph look? My wording is a little off for that one. And would it be better to keep it this way, or should we make it count by 1s? Going on to question 10. All of the boys attending prom wore a tuxedo. The circle graph shows the number of boys wearing each of the different bow tie colors. Here, they do not give me a percent. So what does that mean? I need to find the percent. Make a conjecture. That means an estimate, a guess, an educated guess, not a silly one. Estimate the percent of boys wearing black bow ties by comparing the black section of the graph to the whole graph. What part is black? Give this in fraction form. Then down here it says calculate the percent of boys wearing each bow tie color. How does the percent wearing black bow ties compare to your estimate? Was your guess correct? And I don't mind if you really calculate this out. That's totally fine. So for number 11, you don't have to do number 9. Whoopsies again. I need black out of the total. I need blue out of the total. It needs to be in percent form. It needs to be in percent form. I need green out of the total in percent form. Red out of the total in percent form. Blue, oh, I already did blue. White out of the total. Gray out of the total. And purple. Whoops, percent. Out of the total. So you've got 1, 2, 3, 4, 5, 6, 7 fractions to convert. Once you do the first one, it should be easy because your total is simple. Add up all colors to get the total. Then you'll be done. If you have TTM, do Sunday at 11:59. I know you don't have school on Friday and Monday, but that work is still expected to get done. Have a great weekend.